For this problem, you are told that you have a Taylor series about x equals 5. Now, I haven't talked about what interval of convergence means yet. We will get to that. What it's basically saying, it converges to f of x over a particular domain that you don't need to concern yourself with right now. I want to tell you, though, that this was technically unnecessary for them to write. Did anyone notice that? If I plug in n equals 0, I get negative 1 to the 0 power, which is positive 1, times 0 factorial, which is 1. And in the denominator, 2 to the 0 power is 1, times 0 plus 2. So the denominator is 2. Know that the AP test does this sometimes, where they give you information that you could have found on your own. My guess is they are thinking about how much time it takes you to do this problem, and they need you to be able to do an entire free response problem in 15 minutes. And I think that sometimes they give you information that you should have been able to come up with so that you don't spend that time there. But that almost then ends up confusing you sometimes. But anyway. So this formula actually worked for all of them. Now they blatantly gave you f of 5 is equal to 1/2. So, and I have written down the Taylor formula already ahead of time. From there, use this formula to find the first derivative when n is equal to 1, the second derivative when n is equal to 2, and the third derivative when the n is equal to 3 in the formula. Then you're just going to plop those in and call it a day. First derivative, you don't have to write the simplified form of the fraction. Simplify at your own risk. And so the second derivative is 1/8 divided by 2 factorial. I'll just put divided by 2. Third derivative is negative 3 over 20 divided by 3 factorial, which is 6. And yes, you can. So had you recalled that the formula in general is nth derivative at the center is 5, over n factorial times x minus the center to the power of n. If you took the formula for the nth derivative at the center and substitute that in, you can then simplify and make your life a little bit easier. Replace nth derivative with its formula. And then this n factorial. And that causes the n factorials to cancel each other out. And then it's less plug and chug. So yeah, you can do that. Okay, I'm going to stop the recording.